Recruiters study the final 28 applicants. The strongest coders seem unusually weak at communication. The strongest communicators seem less technical. The dots slope downward so neatly that a story almost writes itself. Maybe technical talent comes with a social cost. Maybe every applicant must trade one strength for the other. But the recruiter is looking through a gate, and the gate can manufacture the pattern it appears to reveal. Start with the full applicant pool. Give every person a coding score from 0 to 10 and a communication score from 0 to 10. For this demonstration, use every possible pair exactly once. That makes exactly 121 applicants across the full square. Coding tells you nothing about communication. The correlation is exactly 0. Look at one vertical slice, and every communication score is still possible. Look at one horizontal slice, and every coding score is still possible. The cloud has no preferred diagonal. Excellent coders can communicate well or badly. Weak coders can too. There is no trade-off hiding in the population we built. Now the company creates a shortlist. An applicant advances when the two scores add to at least 14. That sounds reasonable. A brilliant coder may survive with ordinary communication. A brilliant communicator may survive with ordinary coding. Someone who is merely average at both does not. The rule keeps the upper corner of the square and discards the rest. 28 finalists remain. Inside this selected group, the correlation is -1/2. Nothing about the applicants changed. Only the question, who gets observed? Among finalists, learning that someone scored lower on coding tells you something new. They probably needed stronger communication to cross the same threshold. If their coding score was already very high, less communication was required. One strength can compensate for the other because selection depends on both. That compensation creates the downward slope. The apparent trade-off is not a property of the full pool. It is a property of the gate. This exact direction comes from this exact threshold rule. Other selection rules can create different directions or amounts of bias. The general warning is not, selection always makes a negative correlation. It is, selection can create a relationship that was absent before selection. Causal diagrams give the gate a special name. Coding helps determine selection. Communication also helps determine selection. The two arrows collide at the selected node. That common effect is called a collider. The name describes the arrowheads, not a mysterious statistical substance. Two possible causes point toward the same consequence. Before we condition on selection, the path between the two skills is closed. Restrict the data to finalists, and the collider becomes known. Now evidence about one cause changes what we infer about the other. Conditioning opened a path. The data did not merely lose rows. It gained a misleading relationship. This is why a larger selected sample does not automatically solve the problem. More finalists can measure the selected slope more precisely, while leaving the population conclusion wrong. This trap was described long before modern hiring dashboards. In 1946, a statistician warned about studying diseases using hospital patients. Imagine that either of two illnesses can make hospital admission more likely. In the general population, the illnesses may be unrelated. But inside the hospital, a patient without one illness may be more likely to have the other reason for admission. Hospitalization is the gate. The illnesses are two causes feeding into it. Study only hospitalized people, and the diseases can appear associated even when the population relationship is different. The hospital did not cause one disease to protect against the other. Selection changed the comparison. The same structure appears whenever observation depends on several variables. An elite college sees only students who cleared its admissions process. A company analyzes only employees it hired. A medical study includes only people who volunteered, were tested, or remained until follow-up. A customer survey contains only people who chose to answer. Even a chart of successful creators excludes everyone who tried and disappeared. Each gate may depend on several causes. Once we analyze only the people behind it, those causes can become entangled. Sometimes the gate is obvious, like admission. Sometimes it is a quiet requirement, having complete records, surviving long enough to be measured, or clicking a link. The selected sample may still answer some questions well, but it cannot automatically represent the relationship in everyone who approached the gate. Selection is easy to notice when a researcher literally removes people. The same logic can hide inside an analysis. Controlling for a collider inside a regression tells the model to compare people at the same collider value. Stratifying, matching, or filtering on it does something similar. Conditioning on a consequence of the collider can also open the path. That is why control for everything available is not a safe rule. An extra variable can remove bias. It can also create bias. The variable's causal role matters more than how predictive it looks. Now compare two diagrams. In the first, a third variable causes both the exposure and the outcome. The arrows split from a common cause. That is the classic shape of confounding. Conditioning on an appropriate common cause can close a misleading path. In the second, two arrows point into a common effect. That is the collider shape. Conditioning on the common effect can open a misleading path. The pictures look similar if you ignore the arrowheads. The correct adjustment can be exactly opposite. Causal direction is doing the work. The first repair is not a clever statistical button. It is a better question. What population do we want to understand? Who had a chance to enter the data? Which variables affected entry, observation, and continued participation? Map the selection process before choosing controls. Put causes before effects, and mark every step that decides whether a row exists. When possible, collect information on people outside the gate, or design sampling before outcomes are known. In some studies, weighting, selection models, or sensitivity analyses can help, but those methods need assumptions about the missing people and the selection process. No adjustment can recover information from an invisible gate by magic. The recruiter looks again at the final 28 dots. The downward slope is real inside that selected group. The conclusion about all applicants is not. The company asked coding and communication to compete for the same admission threshold. Then it mistook that competition for a human law. The finalists did not reveal a universal trade-off. The filter created one. Whenever a pattern appears inside a chosen group, ask what chose the group. Before explaining the dots, explain the gate.